to the data channel, and you're watching SQL Bootcamp for Data Professionals. And this is a brand new playlist we are bringing up for the data enthusiasts or the data professionals who want to actually excel in their data professional fields, and especially if you are a data engineer, data analyst, data scientist, right? And whoever is working with a query kind of programming languages or scripting languages, so definitely this playlist what we are bringing will be kind of helpful. And So as part of this introduction video, we will see what are the important topics as a data professional, and as a data professional you might look into SQL, and what are the SQL concept which should be in your radar of learning as a data professional. So that we will discuss in the introductory video, and proceed with the other videos as part of this playlist. So before proceeding, if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notification. So let's get started. So first of all, what is SQL, right, and why it is essential for data engineers? So let's keep it simple. SQL, as most of you might be knowing, it's a structured query language. So why it is called structured? Because it operates on the database, that is a relational database. So if you are working in unstructured data or semi-structured data, so that will not be catered by SQL. So there is a no SQL for catering the semi-structured data, or slightly sparse data which is not in the relational, which will not fit into the relational database in the column and row format, right? So SQL is specifically for structured data, right, which is having a tabular format of rows and tables, and which is data is stored in the relational database. So that is where the SQL comes in handy to kind of manage and manipulate the data within the, which is stored in the database systems. So that is where if you want to generate any reports, you want to do any analytics, right? So then you should write a query on the database to get the data in a required format, and after performing all the required joins and like transformations, whatnot, right? So that is what the SQL in a simple language means. All right. Now coming to understand what exactly why it is essential for data professional, right? So that we will see. So there are a lot of importance for the data professional to learn SQL. So if you want to be data professional, so there is SQL is a mandatory skill set that you need to have. Maybe, as I said, it's a data analyst role, data engineer role, or you might be a data scientist for that matter, or AI/ML kind of a person who is working with the data. So definitely you need to have well versed the SQL concept and its related technologies, and the related technologies and the tools around it, right? So let us see what exactly the why data professionals need to understand SQL, right? So as a data professional, as a data engineer, data analyst, so you will be working closely with the data. So first thing and foremost thing is the data modeling. So if you want to understand data modeling, so data modeling is done in the database system, and it is done using SQL, in the SQL systems, right? And you have a ETL and data pipelines, you have transaction management and asset properties. So asset properties, again, it's very specific to the structured data, right? And we have advanced SQL queries. So let us see what exactly data modeling what we're talking about. So you, like, it might be a database design particularly, right? So what is database design what we're talking about, right? So when we talk about database design, it's nothing but it's a focus on the principle of designing scalable, normalized databases and understanding schema types. It might be star, snowflake, etc. Right? And also when it comes to the ER diagrams, so ER diagrams, like, this entity relationship diagram, because we are talking about relational database. So it's important to learn to kind of create them and interpret them, like entity relationship diagram for the complex data structures. And next is a fact and dimension table. So fact is nothing but it is having a factual details. Like you need to understand the snowflake design on the star design, right? So to kind of concepts around it. So fact is actually factual informations and dim is most of a master data. So you need to understand those role of fact and dimension tables in the data warehouse, right? And next you have ETL and data pipelines, where we talk about ETL or ELT, which is extract, transform, and load. So ETL data extraction is kind of a how to it's about learning how to extract data from different sources like relational databases, APIs, and file system. So there also SQL will come into picture, right? And data transformation, definitely this is where it's extensively used. So you need to master the SQL technique for cleaning the data, joining, transforming, and preparing for the data analysis, right? And finally, if you want to load the bulk data or load the data into the data warehouse databases and optimizing inserts and updates, so you need to know how to optimize that when you're loading into database. You cannot just write into a database table, right? You need to know what are the indexes, what are the part, how it is actually partitioned, and how like it's not about just a loading, right? Again, once you load it, how the reports behave, because how do you write will also depends how exactly the data is readable. If you are writing very badly, so then your read also will go on toss. So these are the couple of things in extraction ETL when it comes to the extract, transform, load, right? And then comes the transaction management and asset proposition. What is transactions? So transaction is nothing but you need to understand how effectively you can begin, commit, roll back, and ensure the data integrity. So you are working in any application, finance, you are working in banking, retail, whatever you're working, right? So there will be transactions, right? There will be daily based transactions will be happening, and the database concept here comes into picture where the data integrity will come into picture if there are parallelly, if there are multiple tables are being written, I mean multiple transactions are writing into same table, same row. So then you need to kind of understand this concept of begin, commit, rollback, and also the deadlock and the table locking, right? So all these things will come into picture. And the next is asset compliance. So asset is atomicity, consistency, isolation, and durability. So this again ensures the data kind of integrity again, right? And there are different isolation levels also. So like if you like there are read committed, read uncommitted, repeatable read, and serializable kind of isolation levels different, and they are having its own performance implications. So let's just next finally we have a advanced SQL. So this is very important, right? And in this playlist, so we'll be discussing more about these kind of concepts where we have a joins, subqueries, CTEs, right? CTEs are nothing but common table expressions, right? Where you can avoid subqueries and make it more performance intensive and more readable also. And you have recursive queries, right? And then you have window functions. Window functions is about ranking, right? So partitioning and running kind of aggregations or etc. Right? So like you can do set operations, you can do aggregations like group by having. On top of that, you can perform sum, count, average, right? So all those will come in the advanced SQL queries, right? So next, continuing in the next slide, we have a SQL security and governance, SQL and cloud platforms, SQL in big data, SQL for data engineering and automation, performance optimization. So yeah, this kinds of concepts, some concepts are theoretical, and some concepts we need to understand by practicing and more of practicals. So it's a combination of both. But in this playlist, we'll be looking of the more practical aspects of SQL, right? And going to the next one, SQL security and governance. So this is again an important topic where uh, the the person or the people who are working so need to understand the user permissions, how kind of how to set up the role based access controls, granting granular level accesses for different roles, right? And granting and revoking privileges to tables, schemas, and databases. And then you have auditing. So you have like auditing where the it's a technique of auditing SQL queries, tracking access, enforcing the data governance policies on top of that. And you have the encryption where you need to understand the best practice for encrypting the data at rest and also in the data at transit. So next you have SQL, and so again there's a versioning also. Versioning is important because as the data grows, or the on a day-to-day basis, the data is getting regularly updated. But if you want to go back by the time and see what exactly this data was looking like maybe 1 week ago or 2 week ago, so then you need to have the provision for versioning the data and kind of going back in the time and understanding what was the data before, right? So that helps in like a lot of production triage issues and understanding like how the sequencing or the data lineage went through over the period of time. So then you have a SQL and cloud platforms. So in the SQL and cloud platforms, again, today we have a lot of cloud vendors like Azure, AWS, GCP, etc. So you need to understand, gain experience of the cloud-based SQL databases like you have AWS RDS, Azure SQL databases, and when it comes to Google, it is Google calls it as a Google Cloud SQL. So essentially, like the syntactically, either you use Azure SQL, AWS RDS, or Google Cloud SQL. It's syntactically it's almost similar with maybe some small difference in syntaxes, but the conceptually everything is same, right? So and serverless SQL engines also, because of the cloud system we have. So Google BigQuery is there, Snowflake and Amazon Athena. So these kind of SQL serverless SQLs are data warehouses are present in the current scenario. So we need to kind of understand how to write the SQL queries in this, right? And the SQL in big data, so we need to write a queries for the massive data sets. So that's also challenging, right? Because we're talking about big data, it's both about volume and the data is constantly getting changed, and working with the massive data sets is really challenging, and effectively using SQL is a key here, because it's not just about writing query, but it is about writing query which is sustainable for the large data sets. So this includes technique like you can take the sampling of the data, approximate aggregations, and data sharding basically, right? So these are the techniques where you can work with massive data sets using the help of a SQL. And there is a distributed databases. So you need to familiarize with distributed SQL engines like Apache Hive, Google BigQuery, Amazon Redshift, and their syntax and optimization techniques. And query parallelism, so understand how to write a query that can be parallelized across multiple nodes in the distributed system, because SQL has evolved over the time, right? So like a traditional SQL was just about like aggregations, like joins, and uh, just kind of creating subqueries and basic operations like indexing and partitioning. But when it comes to big data, so SQL also has kind of evolved to kind of include parallelism across multiple systems, and distribute the load across the multiple systems, right? So then we have SQL for data engineering automation. So when it comes to automation, yeah, definitely the data engineers are responsible to do these kind of automations, right? And writing the scripting with SQLs, use SQL in combination with scripting languages. It might be Python, Bash, for automation tasks like ETL and monitoring. So then we have like we even you can write a stored procedures and functions in SQL, which are a reusable logic with the stored procedures and user-defined functions, like to automate that process, complex data processing. So you can use these kind of functions, which are again SQL related. Finally, we have performance optimization, so which is a favorite topic for most of the, if you are going for the interview or if you are taking the interview, right? So then this is the most asked questions, right? Like how do you optimize like query that you are writing, or how do you optimize the entire ecosystem of what exactly you are using? So then indexing will come into picture, where learn different indexing strategies. It might be hash, it might be b tree, right? And when to use them, which one is suitable for what scenario. you know to how to create, manage, and optimize index based on performances that you're getting on a daily basis. And we have a query optimization. So then it's not about just about indexing, right? So you need to optimize your query. So learn to identify and eliminate performance bottleneck. So you have something called as explain. You can use a query planning, and you can use explain and execution cost for the analysis, and see where exactly you can optimize and where exactly the scope is there to optimize in the code. And apart from code, you have one more option where you can partition the data. So there is a hash partition, list partition, like range partition. Different types of partitions are there for large data sets, and how it improves the performance we need to understand, and which kind of partitions we need to use. And finally, you might be aware that is a normalization topic. So normalization is it's basically it's a known trade-off between normalized and denormalized schema based on the query performance. So basically you can normalize the data into multiple tables and create the things, but you cannot normalize too much also, because if you normalize too much, then your performance query might go wrong. If you don't normalize also, your performance might look wrong. It's a basically it's a balance. It's a trade-off between normalization and normalization to kind of bring it in a common, like bring it to the optimal level, so where it can get the maximum performance. So finally concluding, SQL is definitely a uh, key primary skills, that you want to, if you are want to be in a data professional world, especially like a data analyst, data engineer, and data scientist, and maybe AI ML engineer. And so basically in this video we will be bringing lots of SQL, few theoretical topics to support, but it will be more practical executions of SQL queries, and you'll be able to understand what exactly how exactly we need to write the SQL query, and optimizing the SQL queries and topics around it, right? And definitely we would promise by end of this course, you can, if you follow this course and if you do some practice, you can reach from beginner to master level in SQL. Hope this was useful, and if it is useful, please share it with your friends, and also please feel free to comment if you have any questions. And thanks for watching.